So, based on the information we've had so far, which profile here, you got the red curve, let's call that A, and the blue curve, let's call that B. Which one represents a reactant of the reaction? So you monitor concentration of A and B versus time. Which one is the reactant, which one is the product? Ready? Reactant is A. It's dropping, right? A is your reactant. B is the blue curve represents your product. You start with nothing. Okay, so you're forming it, and then eventually, what happens eventually here? It gets flat. What does it mean when the curve gets flat? Your A and B, your reactants and products are no longer changing. We say at this point right here, you've reached equilibrium, chemical equilibrium. Okay, that's when your reaction is slowest. So when is your reaction fastest? Initially, at time 0, right? Very fast here, very fast over here, at time 0. Okay. One thing you'll notice about this one is your reactant A is not used up. Okay, look at your A. It levels off at some number less than 0.1, but doesn't go to 0. Okay. How can we explain that? That means we say the reaction did not go to completion. The reason for that is all reactions are in fact reversible. Reactions happen because of collisions of atoms and molecules. There's nothing to prevent your product molecules from colliding to give you back your reactant molecules. So when you reach a point known as equilibrium, that's a condition where the rate at which the forward reaction, the conversion of what you consider as reactants into products, equals the reverse reaction, where what you would consider your product molecules reacting to give you back the original reactants. Okay, so this point right here is what we would call the point of chemical equilibrium. That's a dynamic equilibrium. Okay, so the reaction hasn't really stopped. You're not seeing changes in the concentrations of reactants and products because the rate at which the forward reaction is happening is the same as the rate at which the reverse reaction is happening.